Hi everyone, 4.1 Graphing Functions. So graphing functions, we're going to follow some steps when it comes to graphing. This chart right here says graphing functions using a domain of all real numbers. So here are the steps you're going to follow when graphing functions. So the first thing we're going to do is use the function to generate ordered pairs by choosing several values for x. And you can think of setting up even a table with your x values and then your outcome, your y values. Step 2, we then would plot the points that we get from our table. We would plot the points in a pattern for the graph. And then step 3, we're going to connect the points by a line or smooth curve. So these are the steps we'll follow. So let's go and start some examples here. So example number 1. Here we have, it says graph each function for the given domain. They're giving you x minus 3y equals negative 6, and your domain values are negative 3, 0, 3, and 6. So using this formula right here, we have x minus 3y equals negative 6. Our domain, remember, are the x values. Notice these x, negative 3, 0, 3, and 6, they match this. So we are going to use the formula x minus 3y equals negative 6 to plug in to solve for my y. So let's solve for the first one. We have x is negative 3, so we have negative 3 minus 3y equals negative 6. We need to get y by itself. So take care of the value that stands alone, this minus 3 first. So I'd add 3 to each side. Oops, sorry, I keep switching screens here. So I have negative 3, y equals negative 3. Divide negative 3 to each side. Negative 3 divided by negative 3 is going to give me 1. So I solve y equals 1 for the first one. Second one, x is 0, so we have 0. Let me erase this so I don't confuse you here. We now have 0 minus 3y equals negative 6. So remember 0, we don't subtract or add 0, so what I really have is negative 3y equals negative 6. Divide negative 3 to each side. Negative 6 divided by negative 3 is going to give me positive 2. Now let's solve with the formula for x equaling 3. So we have here 3 minus 3y equals negative 6. Subtract 3 to each side. So we have negative 3y equals negative 9. Divide negative 3. So y here is going to equal 3. And the last one we have here is 6 minus 3y equals negative 6. Divide negative 3 to each side. So we have here y equals 4. Negative 12 divided by negative 3 is going to give me 4. So now I can graph the points. So I have negative 3 and 1. So I start at 0, 0, the origin, go to the left, 1, 2, 3. I go up 1 and I plot my point. Whoops. Then I have 0, 2. Whoops. Then I have 3, 3. And I have 6, 4. Notice this has made a linear line, linear graph, so I will connect the points with a straight line. Please use a ruler when you're doing this on the bookwork. I know this is not very straight, showing you with my stylus, but you do need to make sure your lines are straight and using a straight edge when you're connecting them. Moving on to example number 2. Here we are going to graph the function, and we're given domain values. We have f of x equals x squared plus 2. Your domain, your x values are -3, -1, 0, 1, and 3. I've set it up in a chart here. So we're going to solve for our y and then graph our points. So the first one we have is x squared is -3 squared plus 2. Remember, -3 squared means -3 times -3, which gives me +9, plus 2, which is going to give me 11. Now I have -1 squared plus 2, which gives me 1 plus 2 is 3. I have 0 squared plus 2. And 0 squared, ladies and gentlemen, that's going to give me just 0. 0 plus 2 is 2. Now here I have 1 squared. 1 plus 2 gives me 3. Notice a pattern happening right here. If it's -1, it's 3. If it's +1, it's 3. What do you think 3 is going to be? Well, let's see. We have 3 squared plus 2. 3 squared is 9, 10, 11. So my center point's going to be this 0, 2, and notice how it reflects. We have 3 and 3 and 11, 11. Let's graph this. We have -3, 11. It's going to go off the graph just a little bit. Okay, now we have -1, 3. Then we have 0, 2. Sorry, my device is acting up right now. 0, 2. Then I have 1, 3. And I have 3, 11. What you'll notice is this is going to be a parabola graph. Just like that. Let's go into our last example. Here we're working with absolute value. It says graph each function. F of x equals the absolute value of x plus 2. I gave you x values. Now sometimes you might have to think of your own x values, and I'd recommend giving a few negative values and then a few positive values. So I chose -2 and -1, and then +1, +2, and then 0. So if x is -2, we're going to take, it's the absolute value of -2 plus 2. Remember, absolute value is always positive. What's the absolute value of -2? Well, that's going to be 2 plus 2, which is going to give me 4. I have the absolute value of -1 plus 2, which is 1 plus 2, which gives me 3. Absolute value of 0 plus 2, which is going to give me 2. Absolute value of 1 plus 2 is going to give me 3. And the absolute value of 2 plus 2 is going to give me 4. Now this does something similar from the last graph I just showed you, but when we're working with absolute values, our graph is always going to look like a V, or an upside down V. So let's graph these points. We have -2 and 4. We have -1 and 3. We have 0 and 2. 1 and 3. 2 and 4. So notice this is a V here. This isn't going to be a curve like the last graph. Absolute value graphs are always V's. Connect the lines. Connect the points with straight lines, and here we have our graph that represents this function. We'll practice some more of these graphs in class tomorrow.